The first thing you need to do is to set up a data table that looks like this. So you will list what material you have. There will be 6 pieces that we're going to take data on. List the mass of each piece. And then this is going to sound weird, but I want you to list the final volume first and the starting volume second. And then we're going to subtract them to find the volume of each piece. We will start out this density lab by measuring the masses of 6 copper pieces. You'll notice that piece number 1 is the shortest, and they get gradually longer until you get to piece number 6. So I've got a balance over here, and right now the balance reads 0 grams. And I am going to weigh our piece number 1. So record this mass of piece number 1 in your data table. Here's piece number 2. Record the mass of piece number 2 in your data table. Oh, sorry. Here's piece number 3. And you'll notice that they get heavier each piece. At any point, you can stop the video to record the data. This is piece number 4. Each time, I make sure that the balance is still reading 0 before I put the piece on. Here's piece number 5. And here is piece number 6. So at this point, you should have all 6 masses written down in your data table. In order to find the density, we need the masses, which you've already recorded, and we need to find the volumes of each of these pieces, 1 through 6. Since they're a weird shape, I'm going to use a technique called water displacement. So if you look here, there is water poured into the graduated cylinder up to 5 milliliters exactly. So I'll show you each of these so that you can see that they are all filled with water to exactly 5 milliliters. So in your data table right now, I want you to record that each of the starting volumes was 5.0 milliliters. Okay, now I'm going to take piece number 1 here and I'm going to put it in the water, and nothing special really happens except that the volume creeps up a little bit here. Oops, let that thing re-establish itself. And if my old eyes are reading this correctly, it looks like it's at 5.6 milliliters right now, because the bottom of the water curve, that's called a meniscus, is at the 5.6 line. So I need you to record that the final volume for piece 1 is 5.6 milliliters. Now, if we subtract our final volume and our beginning volume, we will find out the volume of the piece of copper that is in there. So 5.6 minus 5 gives you a volume of 0.6 milliliters. Okay, let's do the same thing for piece number 2. Okay, we'll insert that piece. And I'll let you read this one this time. Now we'll go to piece number 3. Let the bubbles settle and get a focus here. You can read that volume. Again, if you need to pause at any point to read the volumes, go right ahead. Piece number 4. Let the bubbles settle. We'll sneak in here. So this time the volume's over 6. Let's see if we can spin that around a little bit more. Okay, piece number 5. Let the bubbles settle. Here you go for piece number 5. And the last one will be piece number 6. And we've got a new volume there. Take a close look at piece number 3 right here. What do you notice on the top of the piece of metal there? How do you think that affects your data? What if I shake it off? Like, what do you think happens to the volume of water that's inside there?